All right, so let's look at this example um, of calculate relative and cumulative relative frequencies. With this one, we're going to look more, not so much at the table and recreating the table, but reading the table. Because these numbers are, kind of quite large. They take a while to kind of type in correctly into your calculator. But what I like about this example, is that it is pretty relevant, to what a lot of us experienced during the COVID-19 pandemic that we lived through. So this is some data uh, from the COVID-19 cases in 2020. So by November 11th, 2022, there had been approximately 96.8 million confirmed cases of COVID-19 with over 1 million deaths in the United States. The US population by November 30th, 2022 was 334,101,821. Below is the frequency table for the number of new cases of coronavirus in the United States by month from January 2020 through December 2020. Okay, this was the first year of the pandemic. So here we've got our categories, right? So the category is a month out of the year. This is the full 12 months for the year 2020. And this frequency column are the number of new cases of COVID-19. So this isn't, new cases plus old cases. Okay, this is simply new cases, new people getting COVID-19. So you can see in January, in the entirety of the United States, there were only 16 cases of COVID-19. And so the relative frequency of 16 cases would be 16 divided by the sample size. And I think for the sample size, yeah, so the sample size, well, I use the sum. Yeah, the sum of all of the frequencies. Okay. Yeah, so the relative frequency, relative to everyone that got COVID, if you add up this entire column, you get 18,504,858. Okay. So compared to, all of the COVID cases that we got by the end of the year of 2020, that's a really small relative frequency, 8.65 times 10 to the minus 7, which when you convert it to a percentage just looks like 0%. And then by February, we had 67 cases. And in March, we went from having like under 100 cases in a month to suddenly having 70,650 new cases. And then it went up by a factor of 10. We went from 70,650 to, in April, 785,283 new cases. So you can see the virus is spreading really fast here at the beginning. And, it seems like the level of new cases kind of evens out, but then kind of explodes again by another factor of at least an order of magnitude from June to July. Now, if you remember, COVID-19, I think, had a incubation period of maybe 2 to 3 weeks. So from the point at which a person was exposed, they wouldn't show symptoms for another 2 to 3 weeks. So, why was there a sudden rise in cases in July? It might have been, again, this is, from my memory here, is that typically people think, like viruses like the flu spread mostly in the wintertime. So you think, well, in the winter, that's the only time you really have to be careful about spreading the flu or any other virus. but COVID-19 was different. Um, and in July, well, you've got the July 4th weekend, right? The July 4th holiday. And so 2 to 3 weeks from July 4th still puts you in the month of July. So perhaps a lot of people thinking, oh, now it's the summer. We don't have to worry about it anymore. July 4th comes around, a bunch of people get together and they spread it to other people. So, we went up from, being in the hundreds of thousands to now being in the millions of new cases of COVID. Then it appeared to kind of drop down a bit. But when I say drop down a bit, we're still getting, 1.4 million new cases in August, 1.1 million new cases in September. And then by October, almost back up to 2 million, like we were in July. And then in November, it doubles, just about doubles to 4 million in November, and then increases to 5 million in December. And again, these are new cases. So in the course of 2020, we had 18,504,858 people come down with COVID. And when you think about over the course of the whole year, we had 18.5 million people get it, and we started with only 16 at the beginning of the year. We started with 16, but we ended with 18.5 million people getting it. Okay. So this was a really highly transmissible virus that ended up, killing about 1 million people. So, this frequency table, is showing the number of new cases, and from that we can calculate the relative frequency. So you just take the frequency in a row and you divide it by the sum of all the frequencies to get a relative frequency. All right. So by just looking at relative frequencies, you can see, we go to having a relative frequency of around 4 here, and then it goes up to 11. Okay, that was July. And then it kind of goes down a little bit to 6, 7%. Then goes up to about 10.5. Okay, that was October. And then it doubles in November. So you can kind of see it doubling here a little bit easier. And then finally, going up as high as a relative frequency of 30%. So almost a third of all of the new COVID cases happened in 1 month all by itself. Almost 1/3 of all new COVID cases were in December compared to the rest of the year. Now, if we use this relative frequency table to get cumulative relative frequency, then you can see how we took this relative frequency and this cumulative relative frequency, added these together to get the cumulative relative frequency here. So you take 0.38 plus 4.24, and that gives you 4.63. You take 4.63, you add it to 4.57, and you get 9.20. So add, you get your cumulative frequency. Add, you get your new cumulative frequency. Add, you get your new cumulative frequency. So now that we've got, this frequency table filled in with relative frequency and cumulative relative frequency, let's take a look at, maybe some questions that we could maybe ask that maybe this table and this data can answer. So what months contained approximately half of all COVID-19 infections in 2020? So we can get that, first of all, by looking at the cumulative relative frequency. So as we're going up and we're adding up all of these relative frequencies, when do we hit about 50%? So you can see just after October, right? If we include all of October and every month previous to that, that's a cumulative relative frequency of 47.8. That's almost 50%. So almost half of all COVID-19 infections took place from January to October. And the other half of all cases happened in just November and December, all by itself. Okay, what was the highest relative frequency of new COVID-19 cases in 2020? And in what month did that occur? So the highest relative frequency was here in December, and that was 30.56. So in 1 month, approximately a third of all new COVID cases occurred in the month of December. And it's like, well, why do you think it occurred in this month? So the reason why, I think it occurred is because of the Thanksgiving holiday. I think a ton of people got together, shared space, indoor space during Thanksgiving, which is at the end of November, thereby exposing one another to COVID-19. COVID-19 has an incubation period of 2 to 3 weeks, which now puts you in December. And then a bunch of people are getting it, are coming down with symptoms of it here in December. So I think it was the Thanksgiving holiday that helped with that increase in the number of new cases. Okay, question 3 is to create a bar chart of the relative frequency and an OGIV graph of the cumulative relative frequency of the data. So here we got a bar chart. So a bar chart is going to show this data in the relative frequency column. So, just by looking at this bar chart, you can see that the number of new cases kind of went up in July, kind of came down a little bit and stabilized, and then gradually went up from September up to October, up to November, and reached its highest in December, where you had almost a third of new COVID cases. So here I chose to, put data labels in to give the exact numbers. I could have done horizontal, maybe dashed lines if I wanted to, but I think putting these data labels actually makes it a little bit easier to kind of see what these numbers exactly were. Then an OGIV graph. This is a graph of the cumulative relative frequency. So what we're looking at as we go from 1 month to the next is how high the next point is relative to the current one. So we go from January to February, there isn't that much of an increase. From February to March, there isn't that much of an increase. From March to April, there's a little bit of an increase to get to April. And then from April to get to May, there's a little bit of an increase. May to June, a little bit of an increase. But you can see here the slope of this line is visibly steeper, which means there's more of a height change, more of an increase to get from June to July. So this is kind of visually showing that there was an increase in the rate of new cases going from June to July. And then the rest, of the months, it does kind of go up, but at a steady pace until October, it goes up quite a bit. You have an increase here in the height to get from October to November, and an even steeper increase going from November to December. So, this is the OGIV graph, of the cumulative relative frequency data for the spread of COVID-19. All right, so this is more of an applied example, to the data that you can get from the World Health Organization, as well as the U.S. Census Bureau, to kind of make this kind of data yourself. So collecting this data, doing the calculations, and actually looking at graphs, can be quite informative, can be quite telling, and communicate certain messages, about how pernicious, this virus really was. Okay, let me know if you have any questions.